action. Here we go. Hi, everybody, and welcome to my talk. I'm Emily Jiang. I work for IBM. I'm the cloud native architect. So I mainly work on open source projects. I work on microprofile, Jakarta EE, and Open Liberty, basically the implementation for the open standard. In this talk, I'm going to talk about monoliths to serverless, and with a few demos as well, and including the IBM Java, and also the new technologies all come with a plus Knative. So everything from monoliths to serverless in 45 minutes. Here we go. So talk about could the modern Java runtime do it all? So we know it's kind of there's a JVM, there's like a Java runtime, Open Liberty, Helidon, Quarkus, and plus some other runtime, Tommy and Tomcat, Piara, and Wildfly. Who knows Open Liberty? Okay, a few hands, great. So for the rest of you who do not know Open Liberty is IBM open source project. It's completely free to use, and also you can get the license if you want to use to get support. So check out openliberty.io. So if you are not, who is using Open Liberty for production? Okay, great. One. So it's for the ones who are not using it. This is the 6 reasons you have to use it. So let me quickly go through it. So it's first, just enough runtime. Liberty is very composable. It has a lot of building blocks, so you can configure them. It will only give you the enough runtime to run your application. And also, it's very low operating cost. Even if you are running Spring Boot, you can deploy Spring Boot to Open Liberty instead of to Tomcat. You can get a huge performance boost. And also continuous delivery. Open Liberty, every 4 weeks, we have a release. So it's basically do the security fix and plus other performance improvement and etc. And also the zero migration. So this is no other runtime offer to you, zero migration. Whenever there's a new release, you do not need to migrate your application. Your current application will continue running in the latest Liberty with no problem whatsoever, because we do not remove anything from the existing Liberty features. And also, Kubernetes is optimized. So we partner with OpenJ9, and also is trying to make best use the Kubernetes features and to see how the JVM work better with the Java runtime as well. And also, last but not least, this is very important, developer experience. I think if you who have been to today's keynote? Okay, a few. So it's so according to the keynote, so 70% of people CEOs think a developer experience is very, very important. So it's a Liberty offer really rich developer experience from the moment you are start writing code to your deployment and monitoring. It has full support. Let's have a quick look about the field. Just enough runtime. So basically, it's controlled by this feature. If you specify this feature in your configuration, it's just a load just enough runtime to run your application to support this feature. But compared to the old WebSphere, it's a load everything, but this is just load enough. And the other thing is zero migration. So it's no runtime feature behavior change, no configuration change, no removal. So we are very serious with zero migration. The other thing is I mentioned the developer experience. Like we have dev mode. Basically, you start your application and then you can code along and you can see the changes straight away. We have support plugins for VS Code, IntelliJ, and Eclipse. Also, we have the repository. Basically, the we have the release to the Docker Hub and IBM repository hub and etc. And then we have support for Maven, Gradle, and for the API, we are seriously into like open standards. So we are strong supporter for and a leader for MicroProfile and Jakarta EE. And for testing, we have the like a macro shell testing. So this is based on the container test containers, and also the support some other framework. So for this, like from the plan to the monitoring, we have all the different tool support and integration. So basically, we embrace all the open source standard and tools and etc. to get you started and ensure you are not into the vendor lock-in mode. So for API, so basically I mentioned again is MicroProfile and Jakarta EE. For Liberty, we are trying to put innovation in the open source standard. So for myself, basically I work for IBM. However, IBM invest my time into the open source a standard such as the MicroProfile and Jakarta EE. So if I have any innovation idea, I just put in the open source project instead of saying, oh, okay, I'm not going to contribute, etc. So this is the thing is we are strongly believe in the future is people should be free from vendor lock-in. That's including the cloud. So hopefully now get you interested in Open Liberty. So check it out. Now is into today's the story from Monolith to Serverless. So there's not a directly jump from Monolith directly to Serverless. Actually, there's a journey. Monolith is a big blob, and then you could do a modular monolith. So basically, also called a macroservices. So it's basically you create some boundary and break these things up, and then to go actually one step further. You just break these ones into microservices. Basically, it's you have use basically it's a different event-driven design or the domain-driven design and a domain-driven design to break them up into microservices, and then you have some smaller functions. So basically, it's need to be triggered and not running all the time. So these kind of functions are suitable for serverless. So you can just directly into this serverless mode. So this is kind of the journey from monolith to serverless. So let's have a look. What kind of the features and requirements for the different architecture? For monoliths, actually, some people still like monolith a lot, especially for the operation team, because once it gets started, it's basically running without any problems, right? It's kind of long running and quite efficient. So it's I know it's who knows WebSphere? WebSphere? Yeah, that's great. I know people, some people do not like WebSphere. I talked with some customers. Actually, they love WebSphere. So they said, okay, once it's kind of almost like a really kind of very built with steel. Basically, once it gets started, it is really, really stable. So it's basically it's long running and efficient. And then the macroservices is long running. For microservices and serverless, they need to fast startup and ramp up time, and also they need to respond to the load. So they should freeze, scale up, and then shrink down. It's very dynamic. We know we are Java developers. Who are not Java developers? Okay, good. So we are all Java developers. We know it. We have when we run a Java application, we have a JVM to deal with. Is JVM good enough for this? Because there's a JVM in the background. If JVM is not good enough for the fast startup, etc., this is screwed up. Basically, it's not good at all. Let's have a look. The JVM. So, how many JVMs do you know? Do you know? 1 or 2? Who think 2 JVMs? Or more than 6? Great. Excellent. So I'm happy to know you do not think you only have 1 JVM. So today I'm going to talk about the beta about JVM. Who do not know JVM? Okay, so I will skip this. So basically, JVM is the guide to make sure write once, run everywhere, right? Because the Java C compile to the bytecode, and then JVM is here to dealing with the particular OS. So basically, there's a kind of translator. Like a JVM is a translator, so translate from bytecode to OS. It takes time. You know, if you you talk a lot, and you have like a translator there, you cannot talk a lot. You cannot talk fast. Otherwise, the translator cannot keep up with it. So this is the issue. So that's why it's like basically there's a problem. Also use your time and use the memory as well. And then in order to improve it, and you have a JIT, like a just-in-time compiler. So this is basically this JIT is this is just a sidekick, trying to help along. However, is after this compilation, and also it's cached, basically stored, almost like a stored procedure. It's like a more frequently used, the method will be compiled and then stored there, and then it's run faster. Whatever you do, and this is still like use up memory and use up CPU. So let's look the performance of JVM on cloud. So the good bit is JVM has been around for more than 25 years, 28 years now. However, one thing is JVM is clever. Basically, is over time is perform better, right? It can learn, and basically it will perform better. And also has a JC. JC is kind of, if you do the Java, you are kind of, if you debug in OOM, so you will know the JC. So the bad bit is about as I say, the translation and also the JIT. And it will frequently cause the CPU spike. The CPU spike, obviously, if a CPU used for the JIT, obviously your application will have less CPU. It will have a less performance. And also the memory spike, and sometimes we cause auto memory. And this is eventually will lead to slow startup and slow ramp-up time. So startup means the time take from application to start to the first receive the serve the request, and the ramp-up time is how long it will take to be more performant. So basically, it's a JIT compiler. So that's not only theory. So we did some performance kind of the experiment. We use a dtrader. So who knows a dtrader? Dtrader? Okay. So that's dtrader actually is also open source project. So it's kind of, you can go to search dtrader. It's a quite big application. So basically we run it and we observe it. You can get a lot CPU spike and memory spike. So this is all caused by JIT compilation. And then in order not to cause OM, you add more memory. However, we know JVM is not predictable, even for the JC is not predictable. You cannot ask JC to run, right? So whenever it thinks it needs to run, it will run. So even though if it's even more even trickier for the container, basically it's difficult to work out how much memory or CPU you need to use, and plus some spike could trigger scale up unnecessarily. So this is quite bad. And at the end, you still got a slow startup and ramp up time. So that's kind of the JVM story. So it's basically we need to minimize the CPU and memory spike and improve startup and ramp up time. That's our ask. So are there any solutions for it? The solution is the GraalVM. So if I can just give you an example here. If you have kids, is kind of does not do well in school, right? And also cannot remember what the teacher said. And you have two solutions, at least two solutions. One solution, probably not, most people will not think adopt out. Nobody will say adopt out, right? Your kids. You're trying to fix a problem because you love it, right? You love them. But I will just use this analogy. Is the kind of GraalVM is pretty much kind of goes to extreme, get rid of the kind of the JVM. So at the end of the day, GraalVM is compiled to the basically your Java code to machine code. So basically, it's you no longer have a JVM in the background. So who are using GraalVM for production? Nobody. And I have not heard any single Fortune 500 companies use GraalVM. The kind of the theory is very simple, because once you use GraalVM, is you almost you sail in the ocean without any lifeboat, because that's machine code. Is all the tools, instrumentations, and metrics is no longer kind of relevant, right? Is you don't have a VM to deal with. You have machine code. There's kind of almost you basically ironed all the Lego pieces together. So there's kind of a lot of risk associated. A lot of things is not working with GraalVM. And the other thing is also there's an experiment the runtime for GraalVM for the runtime performance is not as good as the normal JVM, because normal JVM it will optimize. After you have run for some time, it's learn, and then it's kind of can predict, will give you a good performance boost, but it doesn't applicable for GraalVM. And then now we are not going to adopt out. So it's basically is GraalVM also been talking about people experimented, and I don't think it will go to a lot of adoption. Anyway, that's my personal prediction. So we had a better fix JVM. So what's the solution? Basically what's IBM doing in this space? So it's how to fix the startup ramp up time. So let me introduce you to IBM Java. Who knows IBM has Java? Okay, great. Actually, IBM has Java for over 25 years. So IBM Java. So why IBM has Java? Anybody? Because IBM, IBM stands for what's an international business machine, right? Previously, it had a lot of hardware. IBM still have mainframe, have those. A lot of banks still use this kind of operating system. So IBM want Java to run all operating systems. So that's why IBM has Java. So it's basically IBM have Java for a long time, and However, in 2018, because you know, in the past kind of more than 10 years, IBM into open source a lot, trying to open up like the in-house project and etc. to open source. And then also IBM open source IBM Java to Eclipse foundation called OpenJ9. J9 doesn't mean the Java 9, you know. J9 is basically is the kind of is trying to competing with the K8. Anybody know what's K8? No? It's a small talk. Yeah, you got it. So small talk is K, yeah, after J, but the Java is kind of over years is evolve itself is think better than small talk. So that's user number 9 is bit 8. So that's called OpenJ9. So it's kind of performance-wise is really good for the small memory footprint and fast startup and ramp up time. So OpenJ9 is kind of basically also packaged with OpenJDK as a kind of full OpenJDK. So this is a GitHub repo, so you can check it out, OpenJ9. So for OpenJ9, it's basically for the startup, has 51% faster with the cache and AOT, and also is a smaller memory, 50% smaller memory footprint and faster ramp up and a smaller memory during a load. So it's OpenJ9 is kind of the source code. IBM do the binary kind of download and etc. under the name called IBM Semeru Runtime. So basically, it has 2 editions, or open edition and certified edition. So these 2 got exactly same, identical. The only difference is the license and also the platform difference. And the certified edition is kind of certified like Java SE TCK. So there's no basically no difference apart from a license and etc. So let's have a look at what's IBM Java, what's like OpenJ9, IBM Semeru, like a Java, offer, how to is fix the JVM problem. By the way, Semeru, the name is come from is tallest mountain at island of Java, so that's called Semeru. Yeah. So the first is trying to use JIT as a server, as a service. So basically, JIT is basically is trying to do the hard code compilation. Now it's kind of separate out from the JVM and into a service. So in this time, the Kubernetes can manage it. It can do auto scaling as well. If it's under heavy load, it can stand up new kind of instances. So this is also is kind of mono to macro kind of solution, just separate out. And also the JVM still has its own JIT here. And however, it can, if it's it can delegate out, so basically it can delegate out. If the couldn't delegate out, if this one is gone and etc., it can still fall back to its own JIT. So this is really, really nice. Almost like auto source. So it's so the kind of the this is called a JIT server. So it's available in the OpenJ9 JVM. Also have a free download. It's called also have another name, Semeru Cloud Compiler. It's also called SCC in short. So JIT server. The advantage over JVM client. So basically, it's easier to size. So in your application container, you can just just do the applications performance and etc. And then for the performance, it can basically improve the ramp up time. Basically, it's because it's your application container just consider just do your application code, and then you have a dedicated like a Docker container or some other container directly do the compilation. So the next one is about cost. So you can use Kubernetes auto scaling. So basically you can scale up or scale down. So the last one is you still have your local data. So basically if a data server crash, JVM will fall back to your local data. So you have nothing to lose. So we did some experiment test bed. So basically, we use the Red Hat OpenShift service Rosa on AWS. So it's demonstrate data server is not tied to IBM cloud and etc. It has 3 master, and this is set up, and has 4 applications, Acme Air. These 2 on OpenLiberty, and this is on Spring Boot. This is on Quarkus. So and then is basically we simulate the load and etc. and use the OpenShift scheduler manage the pod. So the output is in this block. So is the turnout is in all of these applications. The data server performed really well, has increased the startup time and ramp up time. So with that, I will do my first demo, and in this demo, I just demonstrate how the data server perform. So basically, I use the 2 service, Grafana and InfluxDB. So this is kind of the collect of this kind of the JMeter data, and go to Grafana. And JMeter is apply load to this Acme Air application. So these are 3 identical Acme Air application. So the only difference, this is the 400 megabyte RAM, this is 200, this is also 200. And they all connected to MongoDB database. The only difference is this one uses data server, and this one too does not. And then this data server connect to Prometheus for the metric, and then can display to Grafana. So let me directly, I have 3 boxes. So basically I go to the remote machine. Can you see it okay? Okay. You go to that database. Go to this folder to have this all the containers. So now here I do the, if you see here, I can start Influx. In here, I can start Grafana. So in here, I can start all the containers. Let me copy the containers to save time. Mongo, data server, Prometheus, Acme Air, and also JMeter Docker. So if I do I show the Acme Air. So as you can see here, so it's the Acme Air. So there's 3 basically the container. So as you can see here, the one is kind of the 400 RAM, 200 RAM, 200 RAM. The only difference is third one has a data server. So that's all you need. Now is let me go to the Grafana dashboard. So here, this one. So basically, is simulate is kind of how the throughput. It will grow over time. And also later on, if I go back to here, it's through the girl dashboard. Server metrics. I think I might do a start clean. Start that. Oh. Let me directly copy that. Let me go to this one. Sorry? Oh, I didn't. Oh, thank you. That's work. That's. Yeah, I think it now is better. Thank you. As you can see here, like this is like a compilation. The basic number the connected client is 1, and also the compilation thread is go up, and also CPU utilization, and also you can see the spike CPU utilization. Now, if we have a look at the JMeter. So you can see the JMeter for 3 ones. So this kind of ramp up really fast, right? A lot faster with the JIT server. And this one is kind of struggling, and because this is only have 200 megabyte, and this is have 400 megabyte is climb up, right? So this is a kind of demonstrate even with the JIT server, and then you have the 200 megabyte, and it's performed really well. Okay, let me go here. Okay, so that's the kind of the OpenJ9. So basically, IBM Java, how did it do to help out with this startup and ramp up time? And then what else is basically what are other kind of solutions trying to improve the startup time? Actually, we also have another like offering, and very hopefully is already in beta. Currently, you can try it out. It's a Liberty Instant On. So Liberty Instant On is built on the CRIU technology. So Linux checkpoint restore in user space. Who knows CRIU? Oh, nobody. Okay. So this basically is kind of is very simple. Basically, is you start up your application, you take a snapshot, and then whenever next time you want like a scale up, so basically is you use that snapshot restore. This is also is called ghosting, right? So basically is you got an image and you directly put that image in a container. So it's basically there's no cold start anymore. Always is hot start. So Liberty and OpenG9 is basically teamed up to just utilize this CRIU technology. So basically, in the build time is a start application, and then it does a checkpoint. And then it's later on it can do the restore. So basically, after done the checkpoint, and then you redo the Docker image, and then you push that Docker image to your Docker Hub. And then whenever like Kubernetes queue the pod, and then it's start another pod, is always get that image already have like all the cache and etc. needed. So it's very quickly can get started. So this is the performance benchmark we did with the instant on feature. So basically, like the application take 128 milliseconds to start for this application. With the database is only take about 213 milliseconds to start. So for the dtreasure, which I said is a very big application, previously it take this 5 seconds to start. Now it's only 310 milliseconds to start. So it's about 10 times reduction in the kind of startup time. And also it's kind of the, so it's basically this technology is very suitable for the container performance boost. Though for usability wise, so basically you do not see any difference. The only thing is what you need to do is you have one extra step when you do a Docker image. So that's all you need. And then is from then on is nothing. Is basically you have that image. That image basically have a memory chip built in, almost like because it's a camera, and take the kind of all the image, and in the future it's just boom. So basically you get everything you need to get started. So it's the other thing is where to do the checkpoint. So you do a checkpoint and install. So at the moment is in Open Liberty we do two position for checkpoint. One is the kind of before application start. So this is the kind of runtime. The Liberty started, and however application has not started, you do a checkpoint. The other one is after your application start, and then you do checkpoint. Obviously, if you do a checkpoint later, is basically you can get a better performance boost. And then you might ask, why not do checkpoint all the time? The thing is, for checkpoint is almost like you take an image, right? If you do start doing the process, like add data to the database and etc., you could have like manipulate in the time you do a checkpoint, and maybe at that time you're trying to store update the data, right? And then afterwards, when you're trying to use that image and to start a new container, that kind of like a data point no longer relevant. So that's why it's kind of, we are really conservative about when to do the checkpoint. We want to be 100% sure you will not get any surprises. So that's why now we are confident like in these two positions, you can do checkpoint, you still get a huge performance boost, but your application, your database and etc. are not affected. So we are not you are not getting duplicate update record and etc. for the database. So it's the other thing is kind of we talk about serverless, and nowadays if you talk about serverless, people automatically think, can you work with Knative, right? So you do not want to tie up with any particular cloud. Let's have a quick look at Knative. Who knows Knative? Oh, brilliant. So I don't need to talk too much about Knative. So for this serving, basically is the kind of works well with the kind of scale to zero and also eventing model. So basically the only thing I want to mention Knative is you might be asking, the Semeru Cloud Compiler, this is the JIT, and instant on, do they work with Knative? Actually, we did a demo and I did a demo. And I have the Knative running, and also some root container running, so the Knative. And it worked really well. My application, I have so many features installed. As you can see, can do so many things. It started within 200 milliseconds. So it's, yeah, as quick as that. Let me quickly show you the, actually, with this is on the, it works on the AKS, Azure Kubernetes Service as well. So here again, so it's, I have this, okay. So as you see, so I can see here is like the Kubernetes, the Knative. So it's basically is in this web address. So I have that automatically started. So here, and basically is this is my application. It's nothing fancy. It's directly basically is display all the basically is the JVM properties and etc. And also is basically this is in the Microsoft Azure. So you can see is the getting started instant on latest. So this is kind of the pretty much like demonstrate actually it worked quite well with all the technologies you use for your like service and etc. So with that, let me quickly go to the towards the end of the slide. So basically, is the journey for service is unlocked with Semeru Cloud Compiler, Knative, and Instant On. So with that, our picture is if you want to do monoliths, you can use Open Liberty, macroservice Open Liberty. Microservice, you can use Open Liberty, some JIT server, Semeru Cloud compiler with Instant On, and serverless you can do with Knative as well. So it's very like simple. The other thing is that also with that, the final one. So it's if I show you here, if I show the my configuration, if I show the so the YAML file is so how simple it is. So you can see here, we use the operator as well. So as you can see, create a TNF service, true, manage TLS, and also pull secret, and then is the checkpoint restore, and then is the kind of you specify the checkpoint. And also the Semeru Cloud compiler, so you say enabled true. So really, really simple configuration, and then automatically install the Semeru Cloud compiler. So here is the kind of checkpoint point. And then that's the end of these slides. So if you want to learn more about Liberty and learn anything about any APIs and etc., we have a lot of guides, and including basically is AWS or the Podman and etc. Is you can all get from this guide. Try it out. So this is the kind of the available resources for you to take away. So with that, I think this concludes my talk. Are there any questions? Any questions? I have stickers, by the way. I think I have stickers. Any questions? All simple? Easy? Do you think I have convinced you to try out Open Liberty? Yeah? So if you can go back and try out at least one guide, I think that would be great for my talk. Yes? Oh, the question is whether I have done any like use JLink to shrink the JVM. Yeah. Yeah, I have heard of that. I heard good stories about JLink shrink JVM and etc. I have not personally tried out, but as my homework, I will going to check it check it out. Yeah. Okay. Are there any other questions? Okay, if not, thank you so much for coming to my talk, and yeah, enjoy the conference. If you have any questions, I'm still around today, but I'm leaving tomorrow. So yeah, looking forward to have a chat with you out of the corridor. And if you want to follow me on Twitter or LinkedIn, feel free. Please send along a request. Where is my Twitter handle? Yeah. Yeah, so that's my Twitter handle there. So it's thank you so much, and see you around.